guys, in the name of God. This is the fourth session of tutorials for Fluid Mechanics 1, Chapter 2, Section 2. We are going to talk about the question which I provided for you from the book Monson Edition 6. The number of question is 2.61 from section 2.8, hydrostatic force on a plane surface. The question is, a homogeneous 4 feet wide, 8 feet long rectangular gate weighing 800 pounds is held in place by a horizontal flexible cable, as shown in figure P2.61 as this. This is the wall. Here we have there's water here. The gate which is held in it, I'm going to write the dimensions, and I'll illustrate the details in further minutes. The length up here is 6 feet, which is the gate, rectangular gate hinge is here. It is hinged to the here. This is the gate. The gate is on a surface connected to a cable from here. The cable is held in it. Water hinge, yeah. The angle up here is 60 degrees. So, water acts against the gate which hinged at point A. This is the point A hinge. Friction in the hinge is negligible. Determine the tension in the cable. So, we have, in the first step, we have to identify the free body diagrams of the gate. I'm looking at my text, so don't worry about it. I'm not going to make mistakes since I have solved it once. We have a gate here. When we have a gate here, like this, the tension of cable is to this direction. There's a resultant force, and there's a weight. And the hinge forces are also exerted in this direction, Hx, Hy. So there's a hinge force here, Hx, Hy, resultant force, weight force, and the tension of the cable. So, how we can calculate the resultant force due to the formula as this. Seems to be dyed out. The marker I mean. It is dying out. I'm going to change the color in order to provide you in a better way. We have a resultant force which is equal to gamma HC multiplied by area. If you don't mention, I'm going to erase the whole body in order to provide more formulas in this area. We have a resultant force which is equal to gamma HCA. HC is equal to 6 divided by 2 multiplied by sine 60 degrees. Why? Due to the triangular equations. We want to have this length. As long as we have 60 degrees, this is HC, which is equal to 6 divided by 2 sine 60 degrees. And the area is also 6 feet multiplied by 4 feet. Since we had 4 feet wide. This is the wide, this is the length. The length of the door. So, and the gamma is equal to 62.4 pound per cubic feet. Doing the calculations, we're going to have a resultant force as 3,890 pounds. So, for now we have we have just calculated the resultant force. But where is it going to be exerted? Here, here, or here? We're going to figure it out. Yeah, that's it. Let me just write the resultant force here. Fr is equal to 3,890 pounds. For the exact location of resultant y, we're going to have formula yr is equal to IXC divided by YCA plus YC. Yeah. YC is equal to 3 feet. Why? Since it is exerted in the middle of the rectangular plane. As long as we have it 6 feet, YC is equal to just half of that, 3 feet. So, IX is gained from figure 2.8, which is equal to 1/12 of 4 feet multiplied by 6 feet cubic. This is A, this is B. If we do the calculation and provide, let me just remind you one thing. The area of here is 6 multiplied by 4. Doing all the calculations, we are going to have YR as 4 feet. So, we have just resulted the exact location of exerting a resultant force, which is 4 feet. So, YR is equal to 4 feet. For having the equilibrium condition, the momentum around this point should be 0. All of them, the combination of all moments. MA is equal to, this is the A, point A here, is equal to 0. We just have the tension of the cable, which is T multiplied by the length of that, 8 sine 60 degrees. And the weight force, which is equal to W multiplied by 4 feet multiplied by cosine 60. Since it is in the since we are gonna we have origin the location of the weight in this scale, we just have to immerse it on another direction, which is having 60 degrees difference. This is something like this. If we have this is the weight. Yeah, this is the 60. Something like this. Due to this, we're going to have this equation. You know, guys, the main reason why we provided 4 here is due to the fact that the resultant weight force is exerted on the YR. So pay attention to this point. Doing plus, plus FR 2 feet. Yeah, FR 2 feet. Plus over here, I forgot to write it down. Plus FR multiplied by 2 feet. 2 is the 4 divided by 2. You know, FR is exerting on the YR, but the half of that. The main reason to this is due to the rectangular plane. When we are having the rectangular plane, the resultant force is going to be exerted on the half of that plane. So, doing all of the calculation, we're going to have the tension of cable as 1,350 pounds. As this. The main point of this question is this section. Pay attention to this. Most likely this point. And also this. So guys, this is the end of 4th session of Fluid Mechanics 2 tutorial, Fluid Mechanics 1 tutorial, for 2nd section of chapter 2 of Fluid Mechanics 1. I'm really glad that you have been with me till this moment of the video. Please don't hesitate to provide your comments or questions in the comments or at the email address I'm going to provide you at the below of this video. Please try to solve it yourself in order to know all of the details of these kinds of questions, and I'm gonna provide you more sessions of tutorial for the second chapter of Fluid Mechanics 1. Please subscribe the channel in order to have the notifications of following videos. Take care, everybody. I bid you all farewell.